Now in example 1 on conversion of bases, Roman number 1, you've been told to convert a binary number system to denary. It is binary because it is to base 2. Remember, the base is expressed as a subscript. Then Roman 2, you've been told to convert a denary number system or a decimal number system to binary. Remember, base 10 means denary. So that Roman 1, if you convert it to denary, you'll get 26.6875 to base 10. Then the second part, if you convert it to binary, you will get what was in Roman 1. You'll get 11010.1011 to base 2. Now, I want to use the case where Roman 1 gives you Roman 2 and Roman 2 gives you Roman 1 for us to see how the process works. Now we'll now start by converting a binary to denary. Remember, we said for you to convert any number system to denary, number system, then you simply find the total value. If you want to convert any number system to base 10, you simply find the total value. And remember, total value is summing up all the digits times their respective place value. So if we have our number line there, so we have the decimal side of that Roman 1, we have, from the decimal side, we have 1 0 1, we have 1 0 1 1. So we are writing down that number. Remember, from the decimal point on the right hand side, we have 1 0 1 1. Then from the decimal point on the left hand side, we have 0 1 0 1 1. If this was a decimal number system, we would have said ones, 100, ones, tens, 100, thousands, in that order. Now in this case, we will now put our base, because it is this number system we've recorded here is a binary number system, so we put base 2. So a binary number system, the base is 2. So it means the place values will have base 2, because we want to multiply these digits and their respective place values. So in the place values, we'll have base 2 because the base of that number is 2. Then we put from the decimal point, we have -1 raised to -2 raised to -3 raised to -4 on the decimal side. Then the whole part starts from 0 for ones, then moves to 1, 2, 3, then the last one 4. So the total value of that number will sum all the digits times their place value. So we have 1 times 2 raised to power 4 plus 1 times 2 raised to power 3 plus 0 times 2 raised to power 2 plus 1 times 2 raised to power 1 plus 0 times 2 raised to power 0 plus 1 times 2 raised to -1 plus 1 times 2 raised to -2 plus 1 times 2 raised to -3 plus 1 times 2 raised to -4. Meaning you are summing up the total value, and you are summing up the digits times the place value. So if you add up the digits times their respective place value, you get the total value of a number. And that total value of any number is always a denary number system, is always base 10. So anytime you look for the total value of any number, you get base 10. And after working out that with the calculator, we found 26.6875. So base 10 is always silent. You can leave it without a base, or you can put base 10 as a subscript to show that the number system you found is actually to base 10, the total value. So base 10 will be 26.6875, then you put base 10 as a subscript, but base 10 is the only base which is silent. So converting any number system to denary number system, you simply look for the total value. Now in Roman 2, we now want to convert 26.6875 base 10 to binary. Now if you want to convert a denary number to binary, meaning we want to convert a total value of a number to binary. For you to convert a number to binary number system, then it is the total value convert to binary. So the whole part, if it is binary base 2, the whole part is divided by 2, decimal part is multiplied by 2. Then you continue dividing the whole part by 2 until you get a 0. So 26 divided by 2, 13, remainder 0, 13 divided by 2, 6, remainder 1, 3 divided by 2, you get 3 divided by 2 is actually 1, remainder 1. Then 1 divided by 2, you get 0, remainder 1. So that is what we have on the whole part. So remember, the whole part of the number system moves upwards. So the whole part moves upwards and the decimal part moves downwards. So the decimal part you multiply. So 0.6875 times 2, you record the whole part which has been generated is 1, then the decimal part remaining there is 0.375. So it is that 0.375 we now multiply by 2. We continue repeating the same process until we get 0. 0.375 times 2, you get 0.75. So the generated whole part is 0. Then we now have 0.75 times 2, you get 1.5. Remove the generated part which is 1, you remain with 0.5. So 0.5 times 2, you get the generated whole part is 1, meaning you remain with 0. So the moment you remain with 0, it means the process suffices. The process terminates, has come to an end. So remember, when you are recording the decimal part, you record downwards. So the whole part you record upwards, meaning you start with the last value, the last remainder. The whole part you start with the last remainder coming upwards. Then the decimal part, so the last remainder is 11010. You start from down, 11010. Then point decimal part, you start from up, the generated number from top moving downwards, which is 1011. So the decimal part you record downwards and the whole part you record upwards. That is what is important. Remember, when you are converting a total value to binary, whole part you divide by 2 until you get 0. Decimal part you multiply by 2 until you get a 0 in that given process. So the process for converting a whole part is very different with the process for converting a decimal part. So there we'll have 11010.11.1011 to base 2. So base 2 is a subscript. So if you want to convert any number system to binary, then it has to be in its total value. It has to be in binary first. Then the whole part, if the base is 2, the whole part you divide by 2. If the base is 2, the decimal part you multiply by 2. In that order. Then the whole part you record upwards, the decimal part you record downwards. Completely two different steps.